Okay, so this unit, we're going to be focusing on a lot of lines that make angles. So, to start off with, let's see how much y'all remember. What are parallel lines?
Lines that never intersect.
Wow, you just said that.
Parallel.
You just said the exact definition. Go get candy for that.
Oh, hey,
Lines that never intersect in our geometry. Okay? They don't intersect. Okay? And we have a cute little symbol for intersect. It's those little lines.
Oh, no.
Up and down. Why don't we do them sideways?
There's a wish that came.
Because it would look like an equal sign and then we'd be confused. Guys, focus. Don't make me call coaches. Okay? You can also do the parallel symbol kind of on a slant if you want, so it doesn't look like an 11. Because that always confuses me because I have terrible handwriting, but you do you. Okay? So they never intersect. Oh, look! Lines that appear to never intersect. I'm going to assume that they are parallel. And if they're parallel, I can mark them as being parallel so I don't have to write words. So to mark them parallel, you either draw these little triangle dudes on them, or you draw an extra set of arrows on them to show that these are the ones that are meant to be parallel. Okay? Can only two lines ever be parallel at a time?
No.
No, look up. Look at all those parallel lines on the ceiling.
Whoa. That's crazy.
Yeah, you could have like 3 lines being parallel. And if they're all parallel, they're all lines, so let me make sure that they're lines. I could show that they were all parallel by putting all the same symbol on them. I know, you're impressed. But look how colorful it is. See, it's so fun to use colors on these. But wait. What if I had another set of parallel lines in the same picture?
Oh my goodness.
How could I show their parallel but not parallel to the pink fellers?
2 arrows. You do like the thicker ones.
I would usually do double whatever I did here. So if I did the triangle ones, I could do double triangles. If I did the chevron ones, I could do the double chevrons. That's what a little slant like this is called, is a chevron.
Oh.
Okay? So, parallels. That's a thing. Questions, problems, complaints, concerns, or comments on parallels? I can tell you're impressed. So, the thing about parallel lines, that never intersect, and I'm going to put a little star on here, is that they are on the same plane. Any 2 parallel lines will always be able to be on one plane. Okay? So I'm going to think of a line. How about the top edge of this whiteboard? That's a line. And it goes on forever. The edge of this table. It's also going sideways, going on forever. Is the edge of this table parallel to that?
Yes. No. No, it's not.
In a way.
Oh, yes, it's not.
They are parallel. And they are even on the same plane. Can you imagine a board that I could take that would connect this parallel line up to that one? Like a big ramp, right? So that would be the plane that would contain those 2 parallel lines. All pairs of parallel lines, you can find a plane they share. You might not be able to see it, but you should be able to create it. And the reason I'm pointing that out is because that's something that happens when you start going 3D. Okay? Because if it's just on paper, it's obvious those are parallel. But when we get into 3D, it can be trickier. Okay? The reason I point out that they're on the same plane is because these guys guys exist. They're called skew lines. When I was in 5th grade, I was in a 5th-6th split class, and so we were doing 6th grade math in 5th grade, and we wrote our own geometry book. And they did skew lines, but their pictures for skew were so bad, I could not figure out what the heck they were. I did not understand what they were until I took college geometry, because nobody ever explained it. So I'm going to explain it to you. Skew lines are lines that don't intersect, but they're also not parallel.
What? So they're on different planes?
Because they're on different planes. So I'm going to color the top plane here.
Oh, yeah.
And I want you to picture this edge of this top plane being its own line. And then I'm going to color this side plane a different color. And I kind of colored over the one that they marked, so I'm just going to use this guy over here. Okay? Because this one is also the same way. Okay? Okay. Now, this blue line and this red line, are they ever going to cross each other? No. This one's going straight up and down. This one's going horizontal, but they aren't touching each other. Do they look parallel? No, this one's going up and down, this one's going sideways. So they're not parallel, but they also don't intersect. And the reason that happens is they're on different planes. Okay? So skew lines are lines in different planes that never intersect, but also are not parallel. And we're not going to do much with these skew lines in this unit because it's a 3D concept, but I wanted you to know that they are a thing. It's possible to not be parallel and still never cross. But that only happens in 3D. When you're on just one flat surface, if you're not parallel, you're going to cross each other. But as soon as you get into 3D space, suddenly skew lines exist. Okay? Could my skew line be on this red plane going at a diagonal?
Yeah.
Like that?
No. No.
Yeah.
Yeah.
Is it still ever going to meet that blue one? No.
It's like three.
Imagine in this room, the one along the top of the whiteboard, running horizontal. Now imagine a diagonal line in the back of the room. A diagonal line drawn on that back wall. Will it ever cross this horizontal line on the front wall? No. But this one's horizontal and the one in the back would be diagonal. Would they be parallel? Also no. So they'd be skew. Because they don't cross, but they're not parallel. Yes?
Wait, what was I asking?
I don't know.
Oh, what is four-dimensional stuff?
It's when you, like space-time. Length, width, height, and time.
It's like.
It's when you have more than four, when you have four things you're measuring in a confined space. It's going to make your brain explode, let's not go there. Yes?
What if the blue line was horizontal, like the very back line?
Oh, so, well then, yeah, that one could intersect, possibly, depending on which red guy you had. But I'm not trying to find out which ones are and which ones aren't. I just want you to understand that they exist.
Yes, ma'am.
Okay? Skew lines exist. All right? Are you done having your brains melt?
No.
Okay, let's melt them some more. So now we're going to talk about the parallel postulate. This is also known as Euclid's fifth postulate, postulate number 5. I just watched an entire 5-video extra credits YouTube series about the parallel postulate. Because it was fascinating. Okay? This can be worded a bunch of different ways, but it all boils down to the same idea. And so the way we're going to talk about it is, if there exists a line, oh look, here's a line, it exists. What's its name?
Line L.
Line L, that's a cursive L. So line L exists. on your line? Do I see any points not on line L? Point P. So if there exists a point that is not on a line, then, so now I'm doing the conditional statement, then there is only one line I can draw through P that'll be parallel to L. Okay? There is only one, count them, one line through point P that is parallel to the other line. And so you think, okay, I've got my line L. I've got point P. See how they've done a dotted line through P? Does it look like it's pretty much parallel to L?
Yes.
Looks pretty good, so let's mark them parallel. Now what I want you to imagine is, could you draw another line through that point?
No.
Well, yes, I could draw infinitely many. But would they be parallel to L? No. Only this one gets to be parallel. That's all you can do. That's pretty much what the parallel postulate says. This is not provable. This is an article of faith. It's one of our 5 postulates of geometry. It's Euclid's 5th. People argued for 2,000 plus years about whether this was something you had to take on faith or whether it was something you could prove. And guess what? You can't prove it. You just have to believe it. What if you don't believe it? Well, it's not wrong. It just means that your geometry looks funny. If you choose that, maybe there's more than one line I can draw that never intersects L. Well, then you have something called hyperbolic geometry. Or maybe you say, oh yeah, I can't draw all the parallel lines will cross L. Every line through P will cross L. And that would look like this. Here's my North Pole. Here is my horizontal line. This line goes through, it crosses L. This parallel line crosses L. They all cross through it. Okay? And so this is a weird kind of geometry. Do you want to learn this kind of geometry?
No.
No? Well, this geometry, triangles have 3 right angles.
What?
I know. Do you want to learn that kind? No. What, Euclidean?
Yeah.
Okay. So we're going to take this as our big 5th postulate, article of faith. We're going to choose to believe this one. That if you have a line and a point, you can only draw one parallel through that point. Could I draw other parallels to the line?
Yes.
Yes, but would they be through point P?
No.
No.
No. Any other parallels would have to be in other places.
Correct.
If I want to draw them through P, it's going to be that exact same one I already drew. Y'all impressed yet?
No, I really don't.
Now, there are 2 kinds of people in this world. Those who can extrapolate from incomplete evidence,
Yeah.
and so for the perpendicular postulate, who thinks you can tell me what the perpendicular postulate says? I will give candy to whoever thinks they can tell it to me word for word. I wonder if it has anything to do with the parallel postulate.
Can I give it a go?
Okay, so Ceci has her hand up. What do you think?
If there exists a point not on a line.
Okay, hold on. So if there exists a point not on a line. Okay, oh look, here's a picture. And here's a line. And here's a point that's not on it. Okay, So if that happens, what are you going to say now?
Then there's only one line through P that is perpendicular to the other line.
Then there's only one line through the point
Wait, why is there twice?
that is perpendicular to the line. Oh, yeah, you're right, you caught it. Get candy. That's supposed to be then. Then there is only one line through the point that is perpendicular to the line. So I have my pink line L, and I have point P. Can I draw a line from P that is perpendicular to L? Yeah, sure, here it is. The perpendicular postulate says that's the only one you can draw through point P. If I tried to draw a different one through point P, it wouldn't be perpendicular anymore. Any other line I try and draw through point P will not be perpendicular. Okay? So that's my perpendicular postulate. Okay, so let's test it out. I need a volunteer who wants candy. I'm going to come up and I'm going to draw Y line. And I'm going to pick a point. I need someone to draw a perpendicular through that point to the line. She can give out candy. I don't have to give it to her. Oh, let's see if we can draw it. Okay, is it perpendicular?
No.
Oh, now it's perpendicular. Okay.
That's terrible.
Now, can I draw another one?
No.
Oh, what? Oh, you think you can draw another one? Oh, you can't? No. Oh, you think you can draw another line from here, perpendicular to that line?
Oh, from there.
No. Are there other perpendiculars that exist somewhere? Of course. But how many through this point?
One.
Just this guy. Again, if you don't believe in the parallel postulate, you could have other perpendiculars. Think of your equator.
Yeah.
Are all these lines of longitude perpendicular to the equator? Yeah.
Yes.
Oh, but don't they all go through the same point?
Yes.
That's the weird spherical. No, that's spherical geometry. It's not. It's all 3D. Okay. Okay. So we'll stick with Euclidean geometry,
Yes.
where this is the only way these guys work. Okay? And then we have one more thing we need to know before we start to get learning new implied statements and junk. And that's this lovely little word called the transversal.
I know that.
And some of y'all know this. Some of you recognize this word. Let's see. What do you... Okay, hold on. Jack thinks he knows what a transversal is.
A line that goes through the two perpendicular lines.
Oh, but you added extra stuff to it. Oof. So a transversal is a line.
A line that goes through two.
And it's a line that does what?
Goes through two.
Oh, what's the fancy math word for going through?
Intersects two.
Intersects. Gentlemen. So what does a transversal intersect? Two or more lines. Yeah, that's it. That's it. That's all a transversal is. It's one line that crosses other lines. Oh, look at the ceiling. Look at all the transversals.
Wow.
Crossing all those other lines.
Why is there gum on the ceiling?
I don't even want to know. Okay?
They thought they were harassment.
So,
If it falls, it's...
my children,
They throw it on there.
in this picture, this would be the transversal.
Correct.
But, and it's a pretty big but, transversals can cross more than one line. So this could also be a transversal, even though it's crossing 3 lines. Can I have more than one transversal on a set of lines?
Yes.
Yes.
Oh, I remember this one.
I've got this dark blue transversal.
I remember this.
Shh. And then I could have this green transversal here. Could I have a bunch of them?
Yes.
Yeah, again, look at the ceiling.
Whoa.
All the lines and all the transversals. Do the lines have to be parallel? No, I never said parallel. They just have to be crossing. So let's do an example. Let's see. I'm going to draw a couple of lines. There they are. I need someone to come up to the board and draw a transversal for these 2 green lines.
Wait, like,
Wait a minute.
does it have to like,
What does a transversal have to do? It has to intersect the 2 lines. Okay? Quentin thinks he can do it. He's willing to try and get candy. I'm willing to give him a shot.
Guys, we need to get the
Go on up there.
okay?
I will trace what you draw.
Alright, so just draw a line.
Draw a transversal.
Hey, she getting fire.
Draw a transversal to those 2 lines. Wow, that's just magical. So let's see if I can trace it. I suck at tracing. Okay, so he'll do something like this.
Look, this still on the back.
Okay. Thank you, go get candy.
Shh.
So, does this pink line intersect the other 2?
Yeah.
It's a transversal. But look what else that means. That means this guy is a transversal for the other 2.
Why? Does that mean that
And the green one is a transversal for the blue and the pink. You can't escape them, they're everywhere.
so easy? What you said isn't like. Did you just say
Wait, that one actually hurt.
I thought it did.
I didn't even see that, bro.
Okay? So,
Did let it hit you?
be careful of assuming. A lot of you started learning about transversals and things back when you were younger. And when you learned them, there were, things were parallel and stuff. No, they don't have to be. Transversal just means you cut across them, that's it. Okay? So the Woodlands Parkway is a transversal to a whole lot of roads, but I promise you it's not perpendicular to all of them. Because it just does all sorts of goofy things. Okay? Now that we have laid the groundwork, this is where the colors will really come in handy.
Yeah.
Who remembers from back in your war flashbacks what corresponding angles are?
I don't know the exact definition, but
Okay, well, give me shorthand. What are corresponding angles in general?
Like a linear pair.
Nope, linear pairs are a very specific thing. Like 1 and 2 would be a linear pair.
on same.
So what makes stuff linear pairs? They're adjacent and they are supplementary. So like 1 and 2. So, corresponding angles specifically cannot be linear pairs. Because they're already a thing. Have you ever heard about shipping? Especially like characters in a movie or a TV show. Or in fanfics. And everybody wants to ship this guy with this girl, or this girl with this girl, or whatever, and everybody's got their own ships. Okay? And so, we're going to have ships here. And the first relationship is corresponding angles. I'm going to give you the basic idea first, and then we'll get the fancy math definition. Corresponding angles are in the same position at different intersections. So looking at this picture, I'm going to color the transversal. That's this guy right here. It's cutting across the other two. And I'm I'm going to circle angle 1. And I want to know which angle corresponds to angle 1. Which one's in the same position? So you look at that corner, and you think, well, it's kind of in the top left corner of that intersection, isn't it?
Yeah.
So you look at the other intersection. Which one's in the top left there? 5. So angle 1 and angle 5 would be corresponding.
Free algebra.
See? Oh, wait, those flashbacks are starting to come back.
I told you so.
Okay. Now,
Two friends.
our corresponding angle's going to be adjacent.
No.
No!
Certainly not.
They're not sharing a ray there. They're not back to back. So corresponding angles are a pair of non-adjacent angles. Okay? Are they on the same side of my transversal or opposite sides?
Same side.
So they're both on the left here, so they're on the same side of the transversal. One is in between, so interior to my 2 lines, and one is exterior. That's a lot of words, huh? I don't like that many words, which is why I like to remember that corresponding angles are in the same position at different intersections. But the important thing is they can't be adjacent. So angle 1 and angle 2 don't get to be corresponding. They're a linear pair, they're adjacent. They don't get to be this. So what I want y'all to do now is, somebody who wants to be brave, what's another set that you think has a corresponding relationship? Okay, AJ? 2 and 6 would be corresponding. So I'm doing these ones in blue. Angle 2 and angle 6 would be. Okay, Zach, what do you think?
Angle 4 and 8.
Angle 4 and angle 8. I'm going to do them in green. Angle 4 and angle 8. Could I say angle 8 and angle 4 are corresponding?
Yeah.
Yeah, doesn't matter what order you say them in. What else? Let's see, I need a different color I haven't used yet. Dark blue. Okay? Ooh, people haven't raised their hand yet. Adeline? Angle 3 and angle 7. Okay.
We're only on the first page.
Yes, maybe I should talk less and listen more so I don't have to keep waiting. Okay? Shh! So now let's talk about a different set of ships. This is going to be our alternate interior angles. Now, remind me, what does interior mean?
Inside of
What do you think we're going to be inside of?
The 2 lines.
Oh wait, I don't have parallels.
The angle. The 2 lines.
The 2 lines. So interior of the double lines. What am I going to be alternating?
Side of the transversal.
That's going to be which side of the transversal. Okay? So, if this is my transversal, and these are my pair that I'm transversing, okay, how would you describe alternate interior angles? It's a pair of something. Okay? A pair of what, do you think? What kind of angles? Non-adjacent. They're not going to be adjacent. Because if they're adjacent, they already are going to have a relationship. They're going to be a linear pair. So we're talking about the ones that aren't adjacent, so they can get their own ships. So a pair of non-adjacent angles. Now if they're alternate, where are they going to be? On opposite sides of what?
transversal.
Opposite sides of the transversal. But what's interior going to tell me? They're both inside the pair of lines?
What?
Okay? It's easier to see it once you've seen it in a picture. So what is one angle that is interior? Just one of the interior angles between the two lines. Just pick one set. Okay, Reese? Oh, sorry, no, Camila, you're next to Adeline Reese. Go ahead. 3 is interior. Which would be its alternate interior relationship? Oh, I like it, the people who haven't answered much are answering. Okay, Haley? 6 would be its alternate interior. So angle 3 and angle 6 would be alternate interiors here.
One's gonna. 5 and angle 4.
What's the other set?
Everybody got it.
Oh, Elliot, were you going to raise your hand and answer that one for us? Yes, Elliot.
Angle 5 and angle 4.
Angle 5 and angle 4. Questions about how those are related?
No.
I'd say that.
No?
I have 0 questions.
Okay, let's turn the page and do some more.
Let's go.
I will give candy. Shh. To whoever thinks they can tell me word for word the definition for alternate exterior angles. Extrapolating from our previous definitions. Cole? Hey, I gotta be able to hear. He's across the room.
Pair of non-adjacent angles.
Okay, hold on, you're talking fast. A pair of non-adjacent angles. Gentlemen. Okay, continue.
On opposite sides of the transversal.
On opposite sides this time, on opposite sides of the transversal,
Both outside the pair of lines.
both outside, what kind of lines?
Double.
The double lines. The 2 lines we're transversing. Okay? So here is a line that is being a transversal to my double set of lines. Are my double lines parallel?
No.
No? How do I know?
Because
The arrows.
Because they don't have the marks. Even if they look parallel, if they're not marked as parallel, don't trust them. Unless I tell you, it doesn't count. So I made non-adjacent angles on opposite, oh, so angle 7 and 8, right?
No.
But they're on opposite sides.
But they're not. 2 and 7.
Oh, but they're adjacent. They can't be these adjacent ones. So what is a pair that aren't adjacent on opposite sides outside the double? Okay, Chloe. Angle 2 and angle 7, that's like a long distance relationship, huh? They're way out there. Angle 2 and angle 7. What's another set of alternate exterior angles? Okay, go ahead, Zach.
Angle 1 and angle 8.
Angle 1 and angle 8.
Zach just said easy.
Well, he's too busy watching. I can't throw an eraser right now. He'll just catch it. Okay.
But I don't agree with
Okay, so somebody else who wants to try for candy. Cole, did you get your candy for?
Yeah.
Okay, thank you. Now, for consecutive interior.
Wow, this stuff is not hard.
Who thinks
Does not challenge me.
for candy?
I am not being challenged by this at all.
Yes, but you are interrupting by constantly talking when you're not called on. So, consecutive interior. Who is very brave and wants to try what you think consecutive interior means?
I got this one too.
Nope, you already did one. Only one chance of suffering per class. Oh, you want to give it a try? No? Okay, well, let me give you a clue. consecutive means same side.
I got it. Oh, wait, no, I don't know. I know which numbers it is, but I don't
Oh,
know.
okay, well, I wonder if I could use previous definitions to figure out current definitions. Okay, we got a victim. He thinks he's got it.
Let's go.
Go for it.
A pair of adjacent angles.
Oh, you already got it wrong. A pair of
Non-adjacent angles
non-adjacent angles.
on same side of transversal
Oh, and how do you know they're on the same side?
because it says consecutive.
Yeah, consecutive means same side, one after the other. So non-adjacent angles on the same side of the transversal,
Inside double lines.
and they're both inside the double line.
Oh.
So, should I have them split that candy since they both contributed?
No.
Yes.
Or should we give it to the person?
I don't get any.
I would get it, I don't want it.
Come on.
You got it wrong. I already had candy.
Okay, well, so why don't you go get it and you can give it to him? But you get to take the parade in front of everybody to get your prize.
Hey, give me a bubble.
Okay, so which angles meet this definition? They're on the same side of the transversal. They're both in between the double line. Okay, Luke?
Angle 4 and 6 and angle 5.
Angle 4 and 6. I can only do one at a time. You're going way fast. Angle 4 and angle 6. Wait! Aren't angle 4 and angle 6 adjacent?
Certainly not.
No.
Not necessarily.
No. Remember, guys? Adjacent angles are back to back. So like 1 and 2, those are adjacent. Okay? Angles that face each other like this is not adjacent. This is consecutive. Okay? And so 4 and 6 are facing each other. They're the same side interiors. What's the other set of same side interior angles in this picture? Okay, Colin?
Angle 3 and angle 5.
Angle 3 and angle 5.
Thank you, my man.
Now, when this set of notes was made, they left off a relationship. So look back through the relationships we have named, and I will give candy to the person who raises their hand and tells me the one that we have not yet named. Oh, I have lots of people wanting to guess this one now.
That's exactly how it goes.
Oh, let's see. I don't get to pick on Chloe much, so I'm going to pick on Chloe. But did she get candy?
Guys, look.
So consecutive exterior.
They are.
Okay, y'all, fill this in at the top. Consecutive exterior, and if you want to, really? So you could also say that these are same side instead of consecutive, and I just do SS for same side interior or same side whatever. So this is same side or consecutive exterior angles. And rather than write the full definition, I'm just going to draw a picture of it based on what it says. I'm going to have a transversal cutting across some kind of two lines. Is my transversal allowed to be sideways like that?
Yeah.
Yeah?
Why not?
Yep.
Yeah, because all I have to do is turn it and then it's up and down.
Yeah.
So it doesn't matter. Okay? Consecutive exterior are going to be on the same side of the transversal, but outside the double lines. And then, of course, there'll be another set that's down here. This purple guy and this purple guy are same side exterior. Okay?
My drawing.
Notice, shh, that these orange ones, are these two orange angles up here adjacent?
No.
No, they're not. They're not touching each other. Are these two purple ones down here adjacent? No, They're not.
No.
They're way across over here. They're on the opposite sides of the river. Okay? So those are all our different ships. Well, the fun thing is, all I have to do is add one more ingredient, and these relationships cause magic to happen.
Magic?
And the one ingredient I'm going to add is parallels. I know, it's a great one. So, oh look, I have a picture. There is a transversal cutting across two lines. What do you notice is special about my two lines?
They're parallel.
How do you know?
It gives it arrows.
I've got the extra arrows telling me they're parallel. Okay? So now I've got parallel lines being cut by a transversal, not just any old lines. These ones are parallel. I can make an implied statement.
Let's go! Yay, finally! I've been waiting all day.
Now, if I have a set of parallel lines and I cut them with a transversal, that's going to create corresponding angles, just like it did with any other double lines. Okay? But if my double lines are parallel, guess what's going to be true about my corresponding angles? Will you stop talking over so I can teach the lesson?
Yes, ma'am.
So let's find a set of corresponding angles. Here's angle 1. Which angle would correspond to it in this picture?
No, angle 5.
It would be angle 5. Now look at angle 1 and angle 5, and what appears to be true about them? They're congruent. When your lines are parallel, your corresponding angles are always going to be congruent. Does that work if your lines aren't parallel? Up here, would 1 and 5, these lines aren't parallel. Do 1 and 5 look congruent here?
No.
No, and they're not. But as soon as your lines are parallel, your corresponding angles will be congruent. But wait, there's more. Guess what?
What?
It's crazy.
It's biconditional. Shh. So the biconditional tells me I can do the converse, which means that if I happen to have a couple of corresponding angles, and they happen to be congruent, what can I know automatically? That the lines must be parallel. So if I know they're parallel, then the corresponding angles are congruent. If I know the angles are congruent, then the lines have to be parallel. So, we already determined that angle 1 would be congruent to angle 5. I'm going to give you 10 seconds, list all the other congruent angles.
I know them.
Write them.
Oh, I already did.
Well, then wait nicely while everybody else does. Since you know them, AJ, what is another set that would be congruent?
2 and 6.
How do you know that 2 and 6 have to be congruent? Shh.
Because the lines are parallel.
And the lines are parallel and
They're congruent.
No.
Corresponding.
they're corresponding. So since I'm parallel, the angles that correspond have to be congruent. That's how I knew they were congruent. Abby, what's another thing I can say? What about angle 3 and angle 7? How do you know angle 3 is congruent to angle 7? I have parallel lines, and those ones are corresponding, so they have to be congruent. Any more?
Yes.
Which ones? Which ones? Easy. What's another set that we'll have to match up? Angle 4 and 8. And how will they be related? I have parallel lines, and how are 4 and 8 related? Which means they have to be congruent. Perfect. an implied statement, guess what you have to do? Memorize it. Learn it, love it, live it. Forward and backward.
Sean said it goes both ways.
It does, but I only heard it the first 20 times he said it.
So you heard him.
Okay?
He's candy.
So, based on that, I want you to now look at this next picture. And I'm going to focus on alternate interior angles. So look in this picture and notice. What do you see about my lines?
Parallel.
They are parallel. Now I want you to look at alternate interior angles. Find a set that are alternate interior. Now, what appears to be true about my alternate interior angles when I have parallel lines?
They're congruent.
So, somebody who wants candy, who can tell me exactly the implied statement I could write for my alternate interior angles? Okay, you're going to give it a guess. Have you already gotten candy?
Yeah.
Okay, we need someone who hasn't. Okay, so Logan?
Parallel lines.
Okay, hold on. Parallel lines.
He's looking.
Or alternate.
You did it. Parallel lines? I'm trying to say an implied statement.
Implies. Yes, implies.
Oh, you said are, so you didn't say the implies.
Alternate interior
Alternate interior
angles.
must be.
Must be what?
What must they be if my lines are parallel?
Congruent.
They must be congruent. And of course, it will be biconditional.
Go get juice.
Go get it. Okay. So, let's write down, since I have parallel lines, what relationships can I get out of this guy now? All you people who haven't answered yet, this is your big chance to get stuff right. You've answered.
I got one. I've got one.
I'll pick on Anna. I have some parallel lines, right? Do I have some alternate interior angles? What would some of those be?
3 and 6.
3 and 6. And what would I know about 3 and 6?
And that since they're parallel lines, then they will be alternate interior angles which are congruent.
Yeah. Since my lines are parallel, this set of alternate interior angles has to be congruent. So angle 3 has to be congruent to angle 6. And so do angle 4 and be congruent to angle 5. And look, you get to memorize it.
Oh, we did?
Fun.
I've even put it in the Quizlet already.
Thank you. That's actually very helpful.
And there's another one. Who thinks, okay, for Katie, who wants to tell me our next implied statement from this picture where I have parallel lines, and I want to focus this one on alternate exterior angles now. Okay? Luke, have you gotten candy yet? Have you gotten candy yet?
No.
Okay, so you can try this one.
Parallel lines imply alternate exterior congruent angles.
Exterior angles will be congruent. Now let's see if that makes sense. What would be a set of alternate exterior angles in this picture, Presley? Just what's a set that's alternate exterior?
2 and 7.
2 and 7, do they appear to be congruent?
Yes.
Yeah, they do. So, okay, I'll buy it. I'll buy his implied statement. You can get the candy, thank you. Oh, and yeah, it would be biconditional, so let's put the biconditional on it.
Let's go.
No. He wasn't wrong. But he's the one who jumped out into the open and was willing to brave that, so. And so we said, Angle 2 better be congruent to angle 7. Why? Because why? Because the lines are parallel and they're alternate exterior, so they have to be congruent. What's the other set? 1 and 8. You're gonna get that stuck in my head now.
I love Mario.
I do as well. I have heard a lot of Mario in my house. I am old.
I have an original Nintendo.
Okay. Now. There's more.
I'm so happy. You can see my smile.
But this one's different. Shh. This one's about consecutive interior angles. Will you find a set of consecutive interior angles in this picture and circle it? Find them, circle them. Remember, consecutive means same side. So I found this set. Okay? That's a set of same side interior angles. They're on the same side of my transversal and they're in between the double lines. Now, since my lines are parallel, do you think these guys should be congruent?
No.
Do they look congruent?
No.
No. These guys have something else special that happens instead. So, poor Candy, who wants to speculate as to what my implied statement will be for same side interior angles? I've got 2 volunteers. I'm going to see who else is willing to give it a shot before I give it away. Oh, y'all are not very adventurous.
Nope.
Okay, you got Candy already, didn't you? No. Oh, I was asking Cole. Zach, have you?
No.
Okay, so Zach's willing to try it.
Parallel lines imply.
Shh, guys.
2.
Hold on, I'm waiting for everyone to finish. Parallel lines implies.
2 angles.
What kind of angles?
Non-adjacent.
Well, I don't want their definition. I want the implied statement.
Consecutive interior.
So the consecutive interior angles, what do you think is going to happen for them?
They're supplementary.
They're going to be supplementary.
Well done.
Only when the lines are parallel, though. And it will be biconditional, and you do have to memorize it.
Okay.
So what would I say up here in my relationship?
Oh, I know.
Please get off your smartwatch and let's focus on our math.
That should be
I got it.
Okay, so, oh wow, lots of people. Okay, Jack?
Angle 3 plus angle 5 are supplementary.
Well, I wouldn't say plus, I'd just say and, or I could say that angle 3 is supplementary to angle 5. Okay?
Yeah.
Now, so angle 3 is supplementary to angle 5. That's the only thing you can get from this implied statement, is that they are supplementary. What's another set I could say? Next victim.
Angle 4 is supplementary to angle 6.
I could say angle 4 is supplementary to angle 6. Now, once I know they're supplementary, what does supplementary imply?
Two angles.
That they'll sum to 180. But, for now, this is all I could say from this implied statement. What's the one we haven't talked about yet?
Oh, the consecutive exterior.
Same side exterior. Guess what, y'all?
We don't do
Well, same side exterior, do you think they'll be congruent or supplementary?
supplementary.
They will be supplementary.
They're going to be supplementary. Any of the ones that say consecutive are going to be supplementary. Same side interior or same side exterior will both be supplementary. But we're not going to put the same side exterior ones on here. Because guess what? It's not on your implied statement sheet. See?
I can't memorize it.
Well, you can memorize it. I'm just telling you we're not writing it. Because we have the corresponding angles are congruent, alternate interior congruent, alternate exterior congruence. All the alternate stuff's congruent. Same side interior supplementary, but look, where's my same side exterior? It's not on here. Darn. Rats. I'm so sorry. You poor thing. Okay. So now, let's go through a couple of the ways I'm going to give you problems with this. So the first thing is, here's a picture. This angle is 120 degrees. I give that to you. I want you to circle all the other angles in that picture that would also be 120. Just circle them right now. Take 5 seconds.
There you go.
You done circling?
Yes.
Oh,
All the ones that you think could also equal 120.
Done.
Okay, so Dominic, what's one of the ones you circled?
4.
Shh. So he says angle 4 would equal 120 degrees. How would I know that? Oh, 4 is vertical to that one, and vertical angles imply congruent angles. Is that one of my fancy new ones?
No.
No, that's an old fella, but it still works, an oldie buddy goodie. What's another one that I could say is also equal to 120? Sorry.
5.
Angle 5. What implied statement can I use to say angle 5?
Parallel lines.
Oh, I have parallel lines.
Yeah.
How do you know?
The arrows.
Oh, the arrows. Okay, so I have parallel lines, which implies what?
Corresponding angles.
The corresponding angles have to be congruent. And since they're congruent, I know that their measures should be equal. Cool. Next victim. Let's see, another, oh wait, was there another way I could have known that that was equal to 120? Could I have said that angle 5 is alternate interior to angle 4? Would that have also made it equal 120? Yeah. There's more than one right answer in math sometimes.
You can take a different.
What's another angle that could be circled as being equal to 120? Camila? Angle 8. Now there's lots of ways to do angle 8. What's one way to prove that angle 8 had to be 120? Oh, she could have said it's vertical to angle 5. That's one we've already used. That's totally legal. What's another way I could have said it had to equal 120?
Alternate exterior congruent.
Oh, it's alternate exterior to the 120 I started with. And so my parallel lines imply that my alternate exterior angles had to be congruent. What's another way I could have said 8 had to be 120? Yes?
it's corresponding with 4.
It's corresponding with 4. So I could have said that the parallel lines imply the corresponding angles had to be congruent. There were lots of ways. And you get to pick whichever one you like best. Could I leapfrog around?
Yeah.
Watch this. We used to do this. I used to put tape on the floor and we would do like Dance Dance Revolution. And so I could say, okay, 120 corresponds to angle 5, which is alternate interior to angle 4, and then that one's corresponding to 8. Therefore, 8 has to be 120. I could have done that. Am I crazy enough to do that? Yes. Are you crazy enough? I don't know. It's up to you. Okay? Now this kind of problem is the kind lots of people got wrong on the Unit 1 test. Because you have to mix algebra and geometry. And some people struggled with that. So, how could I find x? Oh wait, I did. There it is. I found it.
That's funny, I guess.
But I guess we should also solve for x. So what's one way I could figure out how big x is?
150 plus, and then like the x plus 5.
Oh wait, how do I know that? Do they have a relationship?
Yeah.
Yes.
What's the relationship between the 115 and this x plus 5?
Parallel lines multiply.
They keep it professional.
What, do they have a special relationship name?
Oh, yes.
No,
Wait.
they don't. This is not a special angle relationship here. So I'm stuck. How am I going to figure out x if there's no special relationship between 115 and the x plus 5 angle?
You have to use the 4.
Oh, well, what do I know about 115 and angle 4?
It's vertical.
And so how big would angle 4 have to be?
115.
It would have to be 115. See, sometimes you have to pull out the old stuff. Now that I know it's 115, now I still don't know x.
I know how to do it. 75.
Okay, how would I find it? Go ahead.
Since 4 and the x plus 5 are consecutive interior angles,
So I've got some same side interiors.
and it means that they have congruent measures.
Always?
No.
Because I have parallels, those same side interiors have to be supplementary. And what does supplementary imply?
It implies adds up to
180.
They add up to 180 degrees. What's a different way I could have set it up? Look at this. How are these two guys related? They're a linear pair, which means they are
adjacent.
supplementary and adjacent, which means how big would this blue guy be? It would have to be 65. And then, how are 65 and the x plus 5 related? They're corresponding. And since I have parallels, those corresponding angles have to be congruent. So the 65 could equal the x plus 5. That's too, wow. What if I get, I hope I don't get different answers here. Could some of you work the pink guy and some of y'all work the blue guy? Go.
Will do.
Well, that was the blue one. Oh, good. It doesn't matter which way you do it. Guess how big x is?
60.
No, x is 60. Should I put degrees on it? No, because x is not an angle. X is the number you use to find your angles. So the angle is 65 degrees, but x itself is only 60. Okay? So notice there was more than one path to a correct answer. Whichever path works for you. They get there. Yay!
Let's go.
Nope, it's not.
We have one more problem here.
We gotta do one more. Shh. Now, when you get these finite pictures, okay, you're allowed to extend your lines. So where are the parallels? Yes. The left and right? Yeah, the two with the arrows. So could I make these longer to just make it more obvious where my parallels are?
Yes, indeed.
Yes, I could. And then, oh, I've got two letters to find. Garbage. Which one do you want to do first, X or Y? I know we're so basic, always wanting to go alphabetical. So if I do X, notice, shh, X is on this transversal. Do I even need this upper transversal to solve X?
Nope.
No.
So literally, guys, you can cover up the other side. You can get a sticky note or just slap your hand on it.
Are we gonna use patty paper in this class?
Not today.
What the heck is that?
Oh, not today.
Okay? Shh. Listen, it's tracing paper.
Oh,
It's for pre-algebra.
Okay?
I never.
Guys,
What do we do with pre-algebra?
so
That's what I'm asking.
right here, what do I get in this picture that could be useful?
The 90 right angle.
Oh, I have a right angle. What do right angles imply? The measure is 90 degrees. What else do I have that I can get? Their lines are parallel. So, what's a relationship that could possibly be useful? Because guys, we have a whole lot of implied statements you can get from parallel lines. You have to pick the set that you think will be useful here. So what's a relationship, Ibrahim, what's a relationship you think might be useful here? Well, where are you getting that from? What relationship told you that? How are they related to each other? They are consecutive or same side interior. What do I know about same side interior angles? They are going to be, no, they're going to be supplementary. So the 2x plus the 90 has to equal 180. A lot of you had already figured this out in your head. Practice doing the steps, because when we get to the more complicated stuff, you don't want to be skipping steps like in our proofs. Oh, that's you. Okay. So then you could do the algebra. And x would have to equal 45. Okay? Now I want to do y. Is this pink transversal going to be very useful for y?
No.
Maybe not. So I'm going to cover it up, and I'm going to focus on this transversal now. And you look there and you go, okay, are my two brown lines still parallel? Do I still have my parallels?
Yes.
I do. Shh. So now you're going to look for a relationship that might possibly be useful. What's a relationship I could use?
3y and 6y are supplementary here.
How do you know that?
Because the parallel and the...
They're on the same.
What's the relationship?
They're on the same transversal.
And how are they related?
They're consecutive interior.
They're consecutive interior. And if they're same side interior and parallel lines, then they will be supplementary. So now I can say that these two guys have to be supplementary, which implies what?
180.
They sum to 180. So I could say the 3y plus the 6y has to equal to 180. The implied statements tell you everything you need.
I'll let you know what you need to know.
And so then you can do all your algebra.
Yes. You're balling out.
And y comes out to, oh, shouldn't have that, sorry, my bad. So now that y equals 20, should you just accept that or should we check it? Hey guys, it should only take you 5 seconds to check. If y equals 20, how much is 3y?
60.
If y equals 20, how much is 6y? 120. Does 120 and 60 add up to the 180?
Yes.
So now, you've got the remaining time to work on your homework. It's about 20 minutes. Listen! Shh! Pull out the homework and look at problem 1.
I don't have it. Oh, I don't have homework.
Have you sure you printed it out?
I didn't know I had.
It was on the board, and it was in the module. So look, if you don't have it, you can print it out at home. Look, now we've got this same big picture for a bunch of problems, so I'm going to change things up every time. For problem 1, which ones are going to be considered parallel?
A and B.
A and B, but not C and D. So if C and D are not parallel, will 8 and 12 be supplementary angles? No. Because those aren't parallel. Would 14 and 15 be supplementary? Okay? So you're going to have to watch out for what's parallel, because look at number 2, what do?
change it from C.
I change it up. And then these two guys will be parallel, and the other two will not. Are you allowed to redraw the picture in different ways to help you not get confused?
Sure.
Yeah, you could draw the first one where it says A and B are parallel, and C and D are not. You could draw it that way so you don't accidentally make them parallel. Okay? And then for number 2, you could draw these two parallel and make these two guys not parallel. Or you could just use the same picture and keep it straight in your head. Okay? And then for number 3, look what I do just to be evil. I make them both parallel. Okay? So, yeah, watch out for that as you do your assignment, and I'm going to give you the remaining 20 minutes to get going.
AJ,